Create a vector ym17 that contains the centered 17-point average of y. Okay, so ym17 equal to move mean of y comma 17 point average, and plot ym17 as a function of x with pointers and the whole the same thing. Okay, so I'm going to do the same thing. After calculating what I'm going to do, I'm going to plot this ym17. You can see the average thing. You can see the previous graph and the current graph. This is for the ym9, this is for the ym17, and it is using hold on and hold off. You can plot the results in the same graph. Okay, so you have several parameters of this move minimum, move mean. You can also use the other functions like moving minimum, moving maximum, moving sum. Moving mean is what we have seen, moving median, moving standard deviation, moving variance. So all these things you can apply and see what is required for you. Okay, because it's when you're dealing with statistics, you need to find out all these things: mean, median, mode, standard deviation, standard variance, minimum and maximum. So what we have seen is only with the mean or moving average. This can be thought of sliding window protocol. You should study in communication networks, right? So as and when you receive a packet successfully, you will be moving the window in transmitter side and receiver side, saying that one packet has been sent successfully from transmitter to receiver. So this moving average can be thought of as similar thing like that, because I am going to move from left to right, and I'm going to find the average of those signal values present only in that moving window size. Okay. So now we are next topic is we are going to see about smoothing electric data. So how we are going to smooth. This data is very hard, and it is having sharp edges, right? So I am going to now smooth the data using whatever functions MATLAB is going to provide me. So see here, this data contains the monthly electricity usage in US separated by the sector. So it has the matrix. It has for three sectors: residential, commercial, and industrial. We know that the total contain total consumption. So when you add all the consumption of residential, commercial, and industrial, you get the value total. So the months are stored in the timeline in the vector dates. So in the vector dates, the months are stored for which the consumption is given and total consumption is given. Calculate 1 year moving average of total. Add to this the existing plot using markers or a solid layer. Repeat for the 2 year moving average. So I am going to find what is the 1 year moving average and what is the 2 year moving average. 1 year moving average means you have to do it for 12 months. 2 year means you have to do it for 24 months. So see here, I am giving a new variable total equal to move mean of total comma 12. See here, they are asking us to find the moving average of total. So total comma 12. Why 12? I am going to find 1 year. 1 year means 12 months. Hold on, I am going to plot. Same way for 2 year, load 24 equal to move mean of total comma 24. Again plotted, hold off. Okay, hold on will say that so many graphs I'm going to plot, wait, and hold off will say all the graphs are plotted. So you can you can close the window and display it to the user. So here everything is mentioned in months only, right? So I'm going to convert years into month. 1 year average means I'll be giving it as 12. 2 years average means I'm going to giving it as 24. Now let us see if it is correct. Yes. You see two graphs. Maybe you see one in red and one in orange, right? That is 1 year and 2 year average. Almost close. Very minor variations. Otherwise, it is going to be almost close. So when you take data for 1 year, the variation will be more. When you take data for 2 year, the variation will be slightly averaging out. So when you take moving mean for larger number of data, it will be the exact average value of mean. Because more is the data, it will have more accurate results. Okay. So the compared to 1 year mean, I prefer 2 year mean will give you a good approximate of the average electricity consumption in United States